Let's take a look at one more word problem and making sure that we could set up the three equations for this one. So, on this next one, we've got a coin collection that's made up of pennies, nickels, and quarters. So, it would make sense for us, if we're going to use variables, to use P, N, and Q for pennies, nickels, and quarters. But we know that if we add up our pennies, nickels, and quarters, they should add up to 29. So that should make up our first equation, the fact that all my pennies, nickels, and quarters should add up to a total of 29 coins. That's one of my equations. The next equation comes from just the next sentence, which says that the number of quarters is 8 less than the number of pennies. So the first thing is the number of quarters, which is our Q, means equals 8 less than. That means you're going to take away 8 from what? From the number of pennies, P. So that means you're taking away 8 at the end from the pennies. The last equation is going to have to come from the total face value of the coins being $1.77. Well, that means we have to use the face value of all of the coins. Well, we know that the pennies are 1 cent, so that's 0.01. We know that the nickels are 5 cents, which is 0.05. And we know that the quarters are 25 cents, which is 0.25. So we have to use those values. So if each penny is 0.01, we'll do 0.01 times the number of pennies, plus 0.05 times the number of nickels, plus 0.25 times the number of quarters, and this should give me a total of $1.77 whenever I'm done. Notice, just like the last one, they've actually done something nice with Q equals P minus 8, is then we could, in both equations, replace the Q with P minus 8, and then we would only have equations with P's and N's left, and we could just do substitution and elimination, or elimination on just one and 3 with just P's and N's.